Okay, hi, I'm Matt. This is Madhavan. So we've kind of built this presentation. This is kind of an amalgamation of a couple presentations, and we haven't practiced it all the way through yet. So there's probably going to be a couple rough edges. We'll work through those, and I encourage you guys to actually ask questions. Maybe raise your hand if you have any questions. If I missed something that's obvious, let me know. So I want to start by just describing who the two of us are. So I'm a graduate of Carnegie Mellon University. I actually have a bachelor's in information systems. I never even did CS. And I've been at Amazon about 7 years now, which makes me a pretty old fart at Amazon. And Madhavan is a graduate from Purdue. He has a master's in computer science. And he's been at Amazon working with me on my team for about, what is it? 3 or 4 years? Are you coming up on 4? 3, okay. So when I started at Amazon, I worked on a C++ team, and I think that's how I kind of got singled out to come into this. I switched to a Java team, and we can make all sorts of jokes about that in a little bit. And Madhavan's actually been on my team doing Java the entire time, so all 3 years. Just kind of a little bit about us. On our team, we like to pair program, so that's why we have this picture. That I was just searching the internet for like pair programming, and this came up, and I was like, oh, I have to share this with someone else. The other thing we like to do is play our foosball. So we usually settle most of our design debates over a game of foosball, and the loser, you know, his design doesn't win. Okay, so just to give a quick overview of what we're about to talk about, I'm going to go quickly through what our team does at Amazon, just to kind of give you guys a little bit of context so that I can work with that for the rest of the presentation. We're going to talk about the way in which we isolate from our dependencies, and that'll be kind of an interesting thing. That's the new part that I've added. And then we're going to give a presentation that I gave a while ago about TDD, kind of try and synergize that all together. So let's get started with what we do at Amazon. So our team is called Fulfillment Optimization at Amazon. And just at a very basic level, when you order something off the website, we need to decide which warehouse that we want to ship it from to get to you. And it's in our best interest to ship it as quickly as possible, but we need, to ship it as cheaply as possible. And we also need to make sure that we get it to you in a timely fashion, so that you're not just like waiting around forever for it, right? So let's see how we do that. So I have an example of Homer Simpson here, and he wants a donut, right? Pink donut, sprinkles, standard Homer Simpson. And we can see up here that we have a donut that's going to cost $2 to get to Homer Simpson. And we have a donut down here that's going to cost $1 to get to Homer Simpson. So Homer Simpson is our demand. And, well, I guess this donut under Homer Simpson is the demand. And these are our two pieces of supply, right? The obvious choice here is to pick the $1 donut, and in our parlance we call that an assignment, because we're kind of matching the demand for the piece of supply. Okay? Anything to add? Pretty simple? Good. So now we come, and Homer Simpson wants his donut in 6 hours. You can see that up here, right? He's hungry. And we find out that this donut is going to take 2 hours to get to Homer Simpson, and this donut is going to take 9 hours to get to Homer Simpson. All right, so now what we're going to have to do is we're going to have to pick this donut, or Homer Simpson's going to have to go hungry. And Amazon is a customer-centered company, and so we will spend the extra money to get you your donut on time. So here we actually incurred an additional cost of $1 because of that constraint. So Homer Simpson's desire to have a donut in 6 hours is what we call a promise in our parlance. Specifically, we call it a promise delivery date. Because what Amazon is doing is they're promising to you, the customer, that we're going to deliver your item by a certain period of time, right? And I don't know if you guys have been on the detail page. This is like the newest incantation of the detail page I've ever seen. But here I'm trying to buy a banana slicer, a super useful tool in the kitchen. And you can see right over here, I can say order within 2 hours, 32 minutes, and get it on Friday for $3.99 or Saturday for free. Right? This is a while ago. This is not today. So right here, when I choose one of these options and I purchase my thing, Amazon is recording that, like, okay, we promised the customer we're going to get it to them on Saturday, and that's again called the promise delivery date, and it drives the decision that we make. So what's the next slide? We're going to add beer to make things interesting. Everyone likes beer. So does Homer. So now he wants a donut and beer. Terrific combination. And that's gonna, he wants it in 6 hours, all right? So demand. Here's our supply picture, a little bit more complicated, but I think you guys can handle it. There's a donut up here. It's gonna take $2 to get to him in 2 hours. There's a beer here. It's gonna take $3, 2 hours. And there's the donut and the beer down here, but it's gonna take 9 hours, right? So here is actually this is like the worst case, right? Because now we need to send a donut from here and a beer from here. And it's a total of $5, and we call this a split, right? Because we basically had to split this shipment, right? And we have all sorts of metrics around that. And it's issues like this that like make our job difficult. And they become very prevalent when you start ordering 2, 3, 4, 5, 6 items, because there's no warehouse that has all 5 or 6 items. And so you have to figure out the right set of warehouses that's got the cheapest art that also meets these requirements. So, as if that wasn't hard enough, we actually have a number of other requirements that we consider. So I'm just going to walk through these. To make it even more complicated, we can move inventory from one warehouse to another. All right. So if you come back here, maybe it would make sense to move this beer up here, right? And if that, maybe we could move it in an hour. Really fast truck that goes between these two, and then we can ship the donut and the beer to Homer. All right, and it would take an hour to get up here, and then 2 hours to get here, so that's 3 hours, right? And you know, if the shipping of the beer from here to here doesn't cost too much, then we're coming out on top, right? Another clever thing that we could do, and I think this was kind of in the news recently, is that we could say like, oh look, there's a missing beer here, and Homer's probably not the only one that's close to this node that wants a beer and a donut, so we could ship a couple extra beers instead of just the one that Homer wants, right? So that's one thing that we can do, and that's this picture here. Another thing that we consider is the box at the FC, because in the old days, what we used to do, we used to kind of, you know, shotgun like 6 things at the FC and assume that, oh, well, that's going to go out in one box. But it turns out that, like, you know, it would be like a giant book, a CD, and this, and a DVR player, and it wouldn't fit in a box. Yeah. Oh, sorry, that's Amazon parlance for distribution center.
Fulfillment center, warehouse.
I really try hard not to let the Amazon parlance leak through too bad, but every once in a while it does. Thank you for asking. So it's just a distribution center, it's a warehouse, and these were actually back here. These are pictures of them. It's the same picture 3 times. But
they all probably look the same.
This is very much what they look like. They're kind of crazy to go to. I've been to one of the smaller ones, and it kind of blew my mind. So I just want to make sure. The hilarious thing of all of this is I'm on call during this, so at any moment our software could melt down. Okay, so where were we? So one of the things that we consider is the box. All right, so what we used to do is we used to put like 6 items at the warehouse and kind of say, oh, good, that's going to go out in one box, so it's going to be super cheap. But it turns out that in the warehouse, all they have is little boxes, right? And we didn't know that in actuality, what's going to happen is we're going to send out 3, 4, or maybe each of the 6 items in an individual box. And I actually have a pretty funny story I'll share with you about that. There was a warehouse. It was on the Isle of Man, which is near Great Britain, and there was a constraint in that warehouse where we couldn't put, due to like I think a tax reason or something like that, we couldn't put 2 items in a box and ship it. Right? I don't know like how you come up with a constraint like that, but that's what it was. And what someone had done is they had come on Amazon.com, and these little like memory sticks that you see, little jump drives. I think it was a corporate thing, and they wanted to kind of give it to a bunch of employees. They ordered 1,000 of them. All right, and this thing comes bumbling through, and it comes to our system, and we have this this kind of, you can only put it in one box, one in a box. And so, boom, 1,000 boxes start getting picked, packed, and shipped and headed for the customer. And someone along the line was like, whoa, this is no good, right? And so we had to kind of roll that all back, and we had to figure it out. I don't actually remember how we ended up solving that problem, but that was kind of the funniest incident of kind of the box constraint getting in the way.
And that kind of stuff happens in software, right? Software thinks that's the cheapest thing to do, but 1,000 boxes right next door, well, that's really cheap instead of shipping a huge box from somewhere else.
So that was a good story. Do you have a question? Yeah. Okay. Another thing that we consider here when we plan this stuff is we want to make sure that not all the work piles up on one distribution center. All right, so we have a distribution center in Kentucky, and I don't know if you guys know much about UPS, but their like mega headquarters is in Kentucky. And if you actually look, I think almost all of the packages that UPS sends you make a stop in Kentucky. Like they do this crazy thing where they centralize it all in Kentucky and then send it out everywhere. So that's a warehouse of ours. Because it's right there in Kentucky, I think it's actually right near the UPS headquarters, that we love to assign things to there. But the warehouse is only so big and there's only so many people that work there. So if we jam all of the stuff on there, these poor people will have way too much work, right? And then in the worst case, what will happen is we'll get to cases where we think that the customer is going to get their donut in 2 hours, right? But in actuality, the distribution center gets a little bit behind, right? And then 3 hours, 4 hours, and then, oh, it missed the UPS truck that's supposed to take it to the customer. And now we call that breaking the promise, and that's like a horrible thing because we told the customer you're going to have it on Saturday, and then you don't get it until Sunday or Monday, right? So what we do is we have this thing called the load balancer, and the idea there is that we try and spread the load out, making sometimes suboptimal decisions in the interest of making sure that not all of the demand stacks up on one distribution center. And then the last thing we kind of, this is like we consider actually a lot more than this, but I kind of have the most salient examples here. We consider the labor costs in all of the FCs. So sometimes there's an FC where the number of people they can hire, it's like the labor force is more expensive, and so assigning to that FC is inherently a little bit more expensive. I think another case of this is if like all of the FCs are a little bit different, and so like the process in one FC might be a little bit more involved and therefore represent a little bit more money. And so we kind of try and balance that out. Okay, so what's interesting, so that's kind of a cool thing. The reason I'm telling you all of this is I wanted to kind of introduce the notion that Amazon is a service-oriented architecture. I don't know, have any of you heard of that term? Okay, so it's not like a complete crazy made-up term, but so the idea of service-oriented architecture is that our software, while it makes decisions about the boxes, doesn't actually own the calculation on what boxes are valid and what boxes are not. If we had to actually juggle all of that information, it would be very difficult. So the way that Amazon's kind of set up is that with this service-oriented architecture is that there's a service, another team, another stack of software that understands the answer to this question, and we consult that other team when we need the answer to that question, right? And we do that over, HTTP endpoints or message queues or whatever have you. So we call all of these services our dependent services. And one of the big, so here, I need to make sure I don't jump the shark here. Yes, so let's leave it at that because I think I have a slide after this next one about service-oriented architecture. Okay, so I wanted to take a quick break and just talk about how I used to be a C++ programmer and I've gone to Java, and I promised Amy that I would not make fun of any of the C++ developers here. And actually, in honesty, like I don't get that excited about language changes. People will get very attached to their language. I'm one of these people that just use the language that kind of fits the job the best. So when I got asked to do this talk, initially I was a little scared because I was like, well, Amy, I'm a Java programmer. I don't know what I'm going to say to a bunch of C++ programmers. And she was like, oh, it's okay. You can talk about Java. Just don't give them too hard a time. So I was kind of going home one night and I was thinking about like, gosh, what am I going to talk about? And I started thinking about like my old team, which was C++, and my new team, Java. And I was like, well, one of the reasons I switched is because my old team had like all of these challenges that were really frustrating. And when I switched to the new team, all of those challenges went away. And I was like, well, I don't think it was because it went from C++ to Java. And so I started thinking about like, well, really, why are those challenges going away, right? And what it kind of boiled down to at the core of it, which I knew right away, was that my new team practiced this notion of TDD, test-driven development. And we're going to talk about that in a second. But I wanted to kind of pick out like what was the really critical thing about like their devotion to TDD that really made life a lot easier. All right, and I want to make sure I know all the points here. Yeah. So the key thing is related to service-oriented architecture. All right. So let's talk about service-oriented architecture now a little bit, and then I'll draw it back to the Java C++ slide. So with service-oriented architecture, one of the difficulties is that you get like this tangled mess of dependencies, right? Because my service needs to call Madhavan's service, and it needs to call your service and your service in order to answer my question, right? And so what happens is if I want to validate a change for my software, it could be that I have to kind of start up my service with the change and then call Madhavan and call you and like I need to make sure that I'm not doing that in production because I'm not sure if this change is ready to do it in production, like live. So what ends up happening, and Madhavan told me that this is not a concept that exists outside of Amazon, but Amazon has created basically an entire copy of all of the software at Amazon, and we call it Devo for development. And it goes like all the way from the website all the way down to like the thing that prints the shipping label for your box, right? This is a picture of the band Devo. They symbolize Devo. So one of the things that's really difficult about Devo is that like everyone's software is really unstable in Devo because it's all of the development versions of the software. So you know, a lot of times that it's not stuff that's ready for production, it's down, people have forgotten about it. There's sometimes the opposite problem is the case, that people's software lags behind because they forget that they have that Devo instance. Another difficulty is like if you have a change that's coordinated between two teams, you need to coordinate that at 2 points. You need to coordinate the rollout to the development environment. And then once you're done with that, all that hard work, then you have to do it again for production, right? And you have to say, okay, you deploy, and then I'll take an outage, and then I'll deploy, and then you can take the outage and then deploy the other. It gets very complicated. The other problem with Devo is it's really slow because people don't throw all of the hardware that needs to be thrown at it, right? Oh, one more thing. And it's hard to get support for Devo because people don't, again, it's not their primary goal to keep Devo up. Their primary goal is to keep production up. So, what does service-oriented architecture really look like? And let's see if we can do something a little bit better. And this is the new part of the presentation, so it's going to be a little bit rough. Madhavan, help me if I forget stuff. All right? So the new what does service-oriented architecture look like? Well, here I have my fulfillment optimization service, and we've dumbed it way down. And I'm sorry it's in Java. Bear with me. I'm not going to do any fancy Java sorcery, so don't worry.
It almost reads like pseudocode. Everyone can make some sense out of it.
So here we have my optimization service, and it's throwing out a very basic public interface here, where you say pick best shipments. You give it something that represents demand, something that represents supply, and it gives you back a list of shipments. Right? We don't need too many details about exactly what that all looks like. Somewhere along there. Right? One of the important questions that you need to know, or sorry, one of the important answers you need to know when you're picking the best shipments is how much is it going to cost to ship that shipment, right? And what I'm going to do is I'm going to generate a bunch of candidate shipments. I'm going to say like, whoa, well I'll take the pencil and the eraser and I'll put them at this warehouse. How much is that going to cost? It costs $2. Try it at this warehouse, it costs $3, right? So let's just say that's a prime thing that I'm going to give to another service, right? And we're going to call that the Amazon Transport Cost Service, right? So you can see that the traditional approach to this is like this, and you can see my service is calling directly to their service, right? So again, going back to the difficulties of service-oriented architecture, if I change something in these like little comment blocks here, and I want to test it in Devo, I potentially need to have an Amazon Transport Cost Service that's working in Devo. And that can sometimes be something that's very difficult to do. So how do we start isolating ourselves from that? So one of the things that we do, that you start with, is you can put a little layer in between my service and their service. And in our parlance, our team specifically calls that a gateway. Right? And so what do we have? We have the Amazon So here's my service. It's unchanged. Oh, except now it has a transport cost gateway.
It goes like this, right? Sorry.
Yeah, I wanted this up here, but then the text overlapped with this. So, oh dear. So here we go, transport cost gateway, and I've basically just taken this little interface right here, or this little method call that's missing a semicolon, I just noticed. And I've extracted an interface. All right? And then I've re-implemented it, and I've called it the Amazon Transportation Cost Gateway. You kind of get a lot of words jumbled up here. We actually had like a whole discussion about this when we were preparing this slide, because at Amazon, usually this doesn't have a meaningful name like Transportation Cost Service. They usually have a fun little acronym for it. And that's kind of a good thing, because then you can extract an interface that's called the Transportation Cost Gateway, right? And then you can just put that fun little acronym here, and you could just say, well, it's the fun little acronym Cost Gateway. But when you use sensible names like this, it kind of gets a little messy. Anyway, so here we go. We have public class Amazon Transportation Cost Gateway, implements Transportation Cost Gateway, and all he does is delegate straight through. So far, this is not very exciting, right? But we've gotten a layer in between here. So the next step that we do is we spy on this step, all right? How many people are familiar with the kind of pattern of a spy? A mock spy, or, yeah, okay. So the idea there is that what we're going to do is we're going to re-implement the interface a second time. And this time, we're going to inject one of the real copies of their service, right? And as we prepare the data to go to their service, and as we get the response from their service, we're going to store those away somewhere. So you can see that here. So here's my interface, calculate shipment cost, here's the shipment. Go call their service, get the return value, store it in something, super vague here, and then just return the regular value. Okay? And now, we can remove our dependency on them, because what we can do is we can rewrite yet a third implementation of this gateway. And now it's a super simple implementation. It basically is just injected with the storage, and when I say get shipment, I just go look at the storage, return what I see. You can do more clever stuff like, oh, if it's not in the storage, then go try and call the real service, or maybe you want to throw an exception. You do whatever you want. The point of all of this, though, is that what you can do is come back here, and this is the code. So what you could do is you can, in production, you can run this code most of the time, all right? The code that doesn't do any of the overhead of storing anything, right? And what we do is 1% of the time, we run this code, right? And we put this storage in the cloud, right? So for 1% of our orders, what we do is we basically record all of our outbound dependencies, the inputs and the outputs. We store that in the cloud, right? And we actually kind of collect that up into what we call a recording, right? And then what we can do is that we have a version of our service that's plugged in with a bunch of these implementations. And what we can do is we can fire that up, and we can run tests through it, and it will use all of those recordings, and it does not matter if their service is up or down or left or right. We get to basically just do our own little thing. All right? So this is a big win. I want to make sure the next slide.
When we do this for, like, how many services do we call? We call probably, I don't know, more services.
I think it's up to like 27 or something.
Right, something like that. We do that for each of our services, and then we get this huge recording cloud. And I guess, yeah, we do what is like called A/B testing for this actually.
Yeah, so you can take this even further then, and we're, I think, going a little bit. We're going to touch on this again in a later slide, but let's cover it right now. One of the things you can do is you can kind of collect up all of these recordings, and then what you can do is you can have a version of your software that you plan on releasing, right? And the version of the software that represents what you already have running in production. And you can run these recordings through both. And what you've done is you've basically isolated yourself from all your dependencies. And now you can just target your software. You can say, well, these recordings through the candidate release are saving more money than the ones that we ran through the old software. So this is probably a good release. Of course, vice versa, you probably want to stop and take a look.
Are you using any framework for that one, or you develop your own?
So in the end, we kind of developed our own. And
did you look at mock or something for that?
So we also use the mock. You mean like this is Java? I don't know what the C++ equivalent is, but Java has these things called like easy mock and Ito and stuff like that. So we don't use those for this because what we want to be able to do is we want to kind of have a data-driven process for this. So the problem with the mocks is that you kind of need to sit there and you need to say, okay, actually, let's maybe take a step back. Does everyone know what a notion of a mock is? Okay, I'm seeing mostly nods. No? Okay, so the idea of, I'll just cover it really quick. The idea of a mock is there, and it is a little bit of Java sorcery, is that you can kind of take an interface in Java and you can say, look, I'm going to provide like half the implementation of it. And so if someone calls this function, do this, right? And you don't actually ever like kind of write the code. It does it using a bunch of proxy interfaces and a bunch of mumbo jumbo. But the reason that we don't use mocks for this specifically is because we want to have a data-driven approach. And the problem with the mocks is that what you need to do is you need to actually sit down at the keyboard and you need to say, when someone calls this interface like this, do this. We kind of want to be able to make it all about the data so that it's like, look, we're going to collect a bunch of observations from production. And then the data is the thing that's kind of the center of the picture, right?
Are you talking about single thread here or multiple threads? Because what I found difficulty was putting mock when I had multi-thread application. It was not that good in that sense.
So,
I think we don't have a slide on that specifically, but I think we do use both in different scenarios, right? So mocks are more at a unit test level, right? We use those for that. We don't run them in production, so there isn't a problem of multi-threading versus single-threading. So we do use the
but your record of that is
right. So this is a different kind. So we do multiple kinds. So this is more useful for integration testing, where you want to test your software as if it were interacting with real services and getting back real data, except we're taking out the data that we previously got. Right? So that's at an integration test level. We also have unit tests that we run at build time, and for those we do use mocks. So in those cases, yes, we would set up our own hand-rolled data for the unit test.
Yeah.
When you do this recording, are you grabbing per parent original person's purchase, or are you doing it just for each individual shipment?
Yeah, so that's actually really interesting. We actually had some kind of hilarious hijinks when we screwed that up, when we screw up that life cycle. What we want to do is you kind of want to, with service-oriented architectures, what a lot of your software kind of boils down to is there's basically one method that some other service is calling, and it's saying, look, here's a piece of input, do a bunch of calculations and tell me some output. And so what we want to do in that case is we want to do a recording per input to us, right? And in fact, in this recording, I kind of glazed over this, but we actually record our input. So we record all of our dependent services, and then we also record what our input is, and then we also record what our output was in production. And we actually used to kind of use that for that A/B testing, but long story, we stopped doing that.
So in this case, then you are not testing when the other service had a problem, right?
Right, yes. And so there's a risk there, and that's actually a really interesting risk. And it's something that we called out. It's really interesting to talk about that in the context of our pipeline. I just don't know that detail. So one of the ways that you can deal with that is that you can test your algorithm with just the recordings. And when you're done with all, like, just fire 10,000 recordings through it, or however many that lets you sleep at night. When you're done with that, if you're worried about like actually integrating to the service, because something that you could screw up, for example, is when you have these services, there's usually a piece of config that says here's where the service is at, and sometimes you could type that wrong, right? And then this will work just fine, right? Because no one's actually contacting their service. But then when you roll it out into production, kablooey, it all blows up because someone fat figured something in the configuration. So the way that we handle that is we kind of roll out very slowly. So we put it on one host, and we siphon only a couple of requests through, and we make sure that they get from the beginning to the end, right? And then after that, we kind of say, okay, we're probably hooked up to all of our services, and then we kind of progress on.
And we always
That's a good question though, and it's, you can't test it with this approach. Like, you have to break it out.
And service can throw exception also, right, in production, which you are not
Yep.
testing here, right?
Yep.
So we do always have the DEVO, the development environment for that.
Yeah.
So we try not to use that because of all the difficulties and challenges with
Garbage.
it, right? But I mean, yes, if it's a critical thing and something that would cause a huge issue in production, then we always have that to test with, right? So I think if it's really an important thing, everyone makes sure to get their thing up here. And it's just that most of the time people don't maintain it very well. But again, as you mentioned, we try not to do that very often. We just try a slow rollout.
In the back.
So with the replays, are you trying to capture everything in sequence and assume it's going to happen the same way, say with your new candidate software? And how do you handle a case where your new software makes queries that or service requests that the old software didn't?
That's a terrific question. So there's two parts. There's two interesting parts to that question. The first one is, how do you make sure that if you make queries, like let's say that you asked for a shipment in your candidate software that you didn't ask for in production, right? So that's where I was saying, that's where I was saying in this little guy, you can define some semantics. And so what we do in a practical matter is that we have basically, we have a little Boolean that we put in here that says should call real service. And what that does is if it comes down and there's no recording for what we're asking, and that should call real service is true, then what we'll do is we'll go call the real service right then and there and use whatever we see. If that's false, then basically, what do? I don't really know. You could return 0, or if you want to be really kind of intentional about it, you could throw an exception there and say, oh, well, we don't have a recording for this, right? We're going to need to re-record this or something like that. I wanted to touch on the other part of that, which is really interesting, which is what happens when their interface progresses, and now you're recording, or your gateway interface progresses. So like maybe a new piece of data goes in and out of the service, right? And there you do have an interesting backwards compatibility issue. So you need to either need to basically decide, okay, these recordings are getting this new piece of data, and anything that doesn't have that new piece of data is an invalid recording, and we need to delete it from whatever data storage it's in. Or you write like a version of this replay that can handle the fact, like let's say it is a new piece of data, it'll put a fake value in there. You kind of need to just kind of do that on a case-by-case basis. Does that answer your question?
Yeah.
Perfect.
How do you handle performance?
Performance. So, okay. The performance, again, that's another multi-tiered answer. So the performance in real life, like I said, in production we use this implementation, which doesn't do any of this kind of monkey business, right? And so it's just as performant. All you're doing is going through one more layer. But
Except for the 1% or so we record, right?
yes.
So we do store recordings in production for a small percentage. That's why we don't do it for every single request we get. We do it for a very small percent. So.
But I think I know.
What I'm understanding from this and everything you've been talking is you're concerned about correctness and you're concerned about an improvement in optimality of resource assignment, timing, scheduling, all the rest of it. Okay. But there's an implicit assumption, I'm assuming, in all of this, that the system is fast enough.
Yes.
So I don't see anything, that's why I'm asking performance, but I didn't say enough. What happens if your improved system makes things 25% cheaper, but your system runs 25% slower because you're doing more computation? So that's honest.
Yep. And that was remember I said there's a couple of layers to the answer to that, and that's definitely the very important layer. And again, it's kind of like your question. If you want to like test that, this is probably not the best way. You kind of have to call the real service. Now, some other things, if you want to get really like fancy with this, what you could do is while you're recording this, while you're recording, while you're doing this one, the recorder to the storage, you could kind of say like, well, how long did I wait? How how long did it take me to make this request? You can just start a timer right here and end it right here. And you can store that along with the request. And, you know, again, we don't do this, but this would be pretty fancy. You could then just put a little thing that makes sure that this call takes that long or somewhat like that long. And then what you can do is you can kind of see, that actually might be a good idea.
That is probably a good idea.
Then what you can see is, you can see in this isolated context, like, am I kind of performing? And that's definitely like, I think, you know, we've had that issue in the past where we've said like, oh man, this is so much better version of our code. Look at all of these metrics that it does better on, and then we roll it out, and boom, we're calling one of our core services like twice as much. They fall over, and then everything kind of falls over, right? We haven't had one of those in a while though, because of that. I was talking about the kind of we roll out to one machine first, and then we kind of roll out slowly. And these days, doing that, like you'll spot that problem pretty quickly, because some of the metrics that we look at is like, how often do we fail to plan as we're rolling out? Sorry, the plan is like what we do. That's more Amazon jargon that just snuck out of my mouth. How often do we fail whatever we're trying to do? How long does it take? Did that go like up by a whole bunch? If so, then like let's roll it all back and then send us an email, right? And then we can go look at it. Did that? Okay. So I had a couple other tips for doing this stuff. Here they are. So one of the things that we've learned over doing this is try really hard to use your types in the gateway and not their types in the gateway. All right? And I'm going to just switch back to this slide. And the gateway was this layer that isolates you from all of this garbage, right? So you want to try and make the inputs and outputs of the gateway your types, because then you can control them. If it's their types, as they progress their software, you're going to kind of have to do a bunch of stuff. All right? This concept's not just about external services. I know that like it sounded like service-oriented architecture. Not all of us are in service-oriented architecture land. Think of any other external dependencies you have. One of the favorites is a database. You can kind of guard yourself against the database being down. I don't know how often people have the problem when they want to test their software in a development environment and the database just isn't up or isn't available or can't support them.
Or you don't want to go around writing stuff to the database every time you run a test or something like that. Right? You don't want to be doing real stuff.
And then the other thing we learned, and this is actually a mantra on our team, we call it "Don't get abstract." And it kind of actually was born out of like, don't get distracted, and then distract kind of sounds like abstract, and we realized that a lot of the times that we start trying to generalize everything, like overgeneralize, and get really abstract, we're usually distracted. And so what the reason I put that in there is I know a couple other people who kind of tried to follow in our footsteps, and they tried to basically make a super generic layer to handle all of the external services and just basically have the same code. And I think that's a very good goal, like that would be really cool. In reality though, it's really hard to do because there's so many like special cases per service where it's like some take lists of integers and some take lists of longs and some take strings and some take complex objects, and so it's really hard to kind of get everything on the same page. And so the advice that we have is don't get abstract until you have to. So do it for a whole bunch of services, and then if you notice a pattern emerging, then you can extract it out.
How do you figure out that all services are up? Is there anything which is taking the heartbeat of all the services?
You mean in production?
Yeah.
Yeah, so it just turns out, so I glazed over that, but when we do that thing where we slowly roll out, it turns out that for most pieces of work that we do, we kind of touch all of our services. And in fact, when we start up our software, almost all of our services they instantiate a client class that establishes a connection right away. And so if we fail to initiate that client, then we know we don't have a connection, and we'll get an exception, and everything will kind of come tumbling down. So if the software kind of all starts up without exceptions, it usually means we're connected to all of our clients.
If you're using HTTP, there's a connection protocol that you're using. How do you?
If you're using
HTTP to a service, what kind of connection is protocol?
Oh,
I think it keeps those connections alive for a while as long as you have stuff going on the pipe, which is most of the time in production we're making calls constantly, so I think it just reuses the same connection. It doesn't, it might have multiple connections to service multiple threads, but it doesn't require to actually create.
It's an interesting question. I think the reason both of us are kind of scratching our heads is that, like, because service-oriented is so pervasive at Amazon, there's a lot of libraries that kind of hide the details. And so, in my mind, it's like, if you could start the client, well, naturally you're connected. But you're right, like, at the end of the day, there is probably some kind of...
I guess it
I wonder if when all these clients start up, there's some kind of phone home.
There isn't a hard, and there's always also the possibility that it's been started and it's been running for days, and then the other service just goes down in the middle of the night, right? So at that point, request to our service that it's going to start failing, and then there's monitors that will tell us that something's wrong.
That's a good question. Yep, so again, the mantra, don't get abstract until you need to. Okay, so I want to switch gears just a little bit here, and we're going to hook back up with a presentation I'm a little bit more familiar with. So this is all great. We've isolated our dependencies. Now I want to kind of dovetail it into test-driven development. So how many people here, I kind of spoiled the first question I was going to ask. How many people here know what TDD stands for? All right.
So now everyone does.
How many people here think that it actually does stand, the second D stands for development? Does anyone know the dirty secret that, like, there's a lot of people out there that think the second D stands for design, right? And it's test-driven design, and that's, I kind of want to explore why I think people call it that. And so how many people here kind of work on teams that do TDD? Does anyone? It's pretty hard. I know it's really hard to kind of convince people to do it. It seems like we're going to have a whole slide about, like, you know, those difficulties in a little bit. And so we're already down to a pretty select group, but of you that do TDD, do you have automated tests that run as part of your build? Yep, I'm seeing yeses, and if the test fails, the build fails.
No, you cannot even check in the code.
That's so nice. Because, like, a lot of times what I hear is oh, we do TDD, but there's 20,000 tests that we have over here that are always failing, and we don't really care. Just like, well, that's a good point. And then of those people, now it's a pretty select group, how many are actually kind of continuously promoting your software to a production environment? Is anyone doing that? That's a pretty, oh, there's still a couple, okay. So that's a big thing. I think, like, Facebook was the one that kind of, the first big company I remember hearing about that kind of did that already. It's not Facebook that deploys 2 or 3 times a day. Okay, interesting. All right, so we'll take a little time machine, go back to what I was talking about, that slide, that Java versus C++ slide. My old team did not do TDD, and so I'll tell you some horror stories about my old team. So what used to happen on my old team is that you would get a requirement, and you would spend all of this time trying to figure out, like, okay, the business wants to do this now, and I'm going to go find the piece of software in our service that does that, and I'm going to go make the change, and I'm going to try not to break anything else, all right? But it's going to take a while to kind of get it all put in, and then I'm going to build it, and I'm going to put it in Devo. Remember, we were talking about Devo. And then it took forever to, like, test it in Devo because all of the other teams around us would be down. So you'd have to do all of these kind of, like, I'll buy you a beer if you know, help me with this. Like, I just need, you know, a little piece of data that looks like this. And it would kind of go through Devo, right? And eventually you kind of get to the end, and then you deploy in production, and then there would be something that totally changed between Devo and production, and it would be completely invaluable. You'd have to go all the way back to square one, and it would be after, like, probably weeks of effort, right? And so that was like, that really got down on me. And so how does that kind of work? And this is kind of a hybrid slide. We're going to go through this slide twice. So the problem there is that when you find problems in production, it usually takes on the order of days to fix, all right? Because you kind of got to roll it all back, and then you got to kind of make another change, and you got to go all the way back through whatever your release cycle is. And typical release cycles at Amazon are days. If you could find it in Devo, well, then you're talking about hours because it's just basically you. You can go back to the drawing board. If you're talking about Maybe system-wide tests, maybe it's minutes because it only takes a little bit to do system-wide tests. Unit tests takes milliseconds, right? Because you hit that button and boom, it's either red or green. Right? And so this graphic kind of shows you, and I completely made these numbers up, 95% of kind of your problems hopefully are getting caught in unit tests, 4% maybe in system-wide, 1% in Devo, and hopefully 0% in production. Wouldn't that be lovely? Okay, so you're asking yourself, well, how do you do more tests? All right. And so let's introduce the basic TDD recipe. So the basic TDD recipe is you write a failing test. Whenever you need to go do something, you just sit at your computer and you write the failing test, right? And if you're really good at this, you don't let any of your current software kind of dictate to you too much about what that test should look like. You basically find the point that you need to alter and you say, what's the test? You write it. You write the minimum amount of code necessary to make that test green, right? And then this is the step that everyone always forgets, is you refactor when you're done to make the test easy, all right? So I wanted to hit on a couple TDD misconceptions. It's not just writing the test, okay? TDD isn't just you sit down and write the test first, right? That's what a lot of people think. This step is important. You write the test, you write the code to pass the test, and then you refactor it to make all of this simple. I cannot tell you how often I've seen people kind of leave that step out. Yeah, like I just said, it's not just writing the test first. It's not write tons and tons and tons of tests before writing any code. You kind of want to make sure that you start on a simple thing and then work on top of that. So take your problem, figure out the most basic, we call it a walking skeleton. Figure out the most basic thing that you're trying to do and start there and say, okay, well, I have it working for that. Well, now let's add this other angle into it. This is the other kind of, I've heard this one a couple times. Oh, well, the test is difficult because the problem is difficult. And the test should never be difficult. There are difficult problems, but you can usually break difficult problems down into simpler ones. I'm not super experienced, but in my 7 years of experience, there hasn't been a problem that I haven't been able to break down into simpler ones. Or at least moderately difficult ones. So the point here, difficult tests, again, it's a failure to do this step. Because what I've done is I've bent over backwards to write that test, right? Oh, I got to instantiate this class and this class and this class and this dependency and all of this stuff in order to do a simple thing like compute 1 plus 1, right? So I write that complicated test, I write the code that passes that test, and then I walk away. What TDD is trying to tell you is it's trying to tell you, okay, now use the fact that the test is really complicated, right, to help teach you how to alter your design, right? And if I can make the test simpler, then the design should be better. That's the kind of core thesis of TDD, is that it's all about TDD, simple tests equals simple design. And there are some special cases where maybe that's not the case, but for the most part, these TDD people, including me, will argue that is the case. And then the last thing I'll say, this was kind of a presentation for people at Amazon that had, maybe there were a couple teams that had done some tests, and one of the things that I sometimes hear is like, oh, but it's so hard to write the test that it's just not, it's going to be super brittle and all of that stuff. And I want to point out that bad tests are worse than no tests, because the worst case you can just delete a test if it's bad, and that's a really bad outcome. That's what I call declaring bankruptcy. But if the test is really bad, it's always breaking every time you touch the software, and it's not for any good reason, out it goes. And that's kind of a double negative there, right? This is coming out as a misconception, so saying that a bad test is still better than having. You're right, it's not a misconception, so it is just a conception. Well, is that what you're saying? No, I'm saying it is, having some tests at all is still better, right? You want to build on that. If it's bad, if you can throw it out, or you can build on top of it and make the test better, right? You don't want no tests. That's really bad. So I made a dubious claim when I think I was describing one of these points up here. I said that TDD equals good design. And so let's see if we can defend that claim a little bit. So why is TDD equal good design? So let's talk about what are usually the hallmarks of good design? Well, low number of bugs, that's probably a pretty good one, right? Whoops, documentation and readability, that's a pretty favorite one. Modularity and extensibility, that's a huge one. Good design should be really, I think you call it supple design. That's what, is that a different, we don't want to get into that?
I don't know, that comes from like...
So modularity, extensibility, very pluggable, and then efficiency runtime. I think that's kind of an interesting one. Okay, so how does TDD match up with this? Well, number of bugs. Well, you've got that. You've got failing tests, right? And hopefully, if you're good at being disciplined about your tests, you will cover all of your edge cases. Of course, you know, sometimes you miss one, but you're doing better than not having any tests, and you know that you won't be releasing a bug because hopefully the test will fail if you introduce a bug. Documentation readability, for me, this is like the one that's big for TDD. When you write unit tests for a chunk of software for a unit, you're self-documenting that unit. Especially if you get really kind of good at doing these tests, and practice makes perfect. You can basically make the test read just like, you know, you open up the test and it says, well, this unit, when it started with this and this and this, it should output this, right? And you can just read that and people can say, oh, I get what this unit does. Modularity and extensibility. So when you do test-driven development, in order to make things testable, you have to make sure that you can inject a bunch of dependencies, because what you need to be able to do is you need to be able to inject, if a class collaborates with two other classes, you need to be able to inject versions of those two other classes that can do kind of mock behavior, that can return 1 always or return 0 or whatever you want, so that you can write your unit test about it. Because what you're saying, if my class collaborates with you, I want a version of you that always returns 1, and then I can write assertions against myself, knowing that you always return 1, and I do whatever I need to do with that. So you get modularity and extensibility out of that. Efficiency, TDD doesn't really give you this one, unfortunately. It's not going to make you write super efficient code. However, you can kind of cheat. If efficiency is really important, you can write a test that shows, like, an example of this is if you want to make sure that an algorithm is kind of n log n time, you can inject a little dependency that counts the number of times that you call some critical piece of code. You can count it up. You can run it on a set of 100 things, run it on a set of 1,000 things, and compare how many comparisons are doing, and you can write a test around that. But you know that's a little bit of a stretch. TDD is not really giving you efficiency. That's the one thing it kind of does for you. Okay, some additional feedbacks of some additional benefits of TDD. You get this kind of feedback on your quality of the code, and that comes in the form of how hard it is for you to write those tests, right? If it's really hard for you to write those tests, you probably have a lot of hidden dependencies or a lot of coupling that you probably don't want. This is a big one for me. I kind of get scatterbrained sometimes. Sometimes. I get scatterbrained all the time at the keyboard when I'm programming. And I'll kind of start working on something, and then I'll find myself over in this corner of the code over here cleaning up some other mess that I just saw that really has nothing to do with what I originally done. So one of the things that red test helps me do is it helps me stay focused. I just focus on making that test green, and I won't go and get distracted by this over here. Oh, this is a big one. It's been a while since I've given this presentation. When you break all of these things down, you can debug units rather than huge conglomerations of a bunch of collaborators. I think this is really just kind of fallout of having a more modular, extensible design. So you can drill down to those little units, and understanding the unit is much easier than understanding a collection of units. And then there's the obvious benefit of you have all these unit tests that are a safety net for you. So if you make a mistake over here that breaks something over here, that would be a failing test. And then again, speed. This is the controversial one. This is always, we always do this on our team. We kind of play devil's advocate, and we say, well, unit tests are stupid. I have to write twice the amount of code, right? So it's going to take me twice as long. And then we also pair program, so that's 2 people. So now we're at a quarter efficiency. Well, what a waste of time. And you know, when I did this presentation, I tried to find some studies on this. And there are some floating out there. I don't remember where they all are. There was actually one out of Microsoft that says they did some studies over teams that did similar things, and one had a TDD approach and the other didn't. And the team that didn't do TDD was faster initially, but kind of eventually their productivity kind of leveled off because they started chasing a lot of these kind of, oh, we deployed it to production, now we have to roll back because we didn't have any unit tests telling us that we broke this assumption over here. Whereas the teams that did do the TDDs, they were kind of able to kind of maintain a steady kind of productivity curve. So controversial, you have to write twice as much code. Sometimes though, you know, if you're clever enough, sometimes it enables you to write far less code. Oh, and this is one I added just for this. We were talking about this, one of the things, we try to work on our team, or on our code as a team. And so one of the difficulties is if an individual writes a bunch of stuff over here, the team doesn't really understand how that stuff works. And so now if I get hit by a bus or I quit, and you later have to go work on this stuff, it could be very hard for you to understand all of the assumptions that I've made over here. Whereas if I kind of leave behind a bunch of tests, then it's going to make it a lot easier for you to come over and work on that stuff.
I think it goes back to the self-documenting thing, right? Like, especially a lot of internal stuff, like public APIs, they usually have documentation on people are going to complain, but nobody ever writes documentation for internal stuff, but at least tests give you that self-documenting thing. If somebody comes tomorrow and looks at this.
I actually have a funny story on that one too. Do you remember, was it Yavor? We had an intern, and he came and he worked on our team, and we taught him TDD and pairing and all of this good stuff. And one of the things that we do on our team is if you're sitting down and you're about to write this really kind of wordy comment, then you need to kind of step back and say like, wait, have I like kind of made everything way too complicated? Do I need to break this down into smaller pieces? And so we kind of have this thing where we say like, look, try not to write comments in your code. And he was an intern, and they do this process where the internship is done. They have like a meeting where they talk to the intern and they say, what did you learn? What did you work on? And it's kind of like a mini interview. And this intern of ours, Yavor, he said, well, I don't write documentation in my code. And there was a senior engineer that was that wasn't connected to our team, completely separate. And apparently, like, I wasn't there, but apparently he was like, whoa! And he kind of freaked out. And they ended up, like, kind of getting me in a meeting room and leaning on me. I said, it's not that we don't write documentation. It's that we think that if we're sitting down to write documentation, let's just make sure that it is actually something we need to document and not just something that's too complicated. We break this problem down into smaller pieces. All right, we're getting near the end, guys. TDD Pitfalls. These are more of the, oh yeah.
So do you say you don't comment your code?
I try not to comment my code. I do comment though, and so this is basically I think what sets me in the old days on my old team, C++ team, I did comment a whole bunch. And so what changed? What changed is when I'm about to write a comment in code, I stop and I say to myself, do I really need to write this comment, or am I just compromising the design here? Like, is there something? Can I break this into two classes that are themselves self-descriptive, right? And if I kind of spend a couple minutes thinking about that and I can't come up with something, go ahead and write the comment, right? But more often than not, what I find is I'm like, wait, why am I having to write this comment? Oh, it's because this piece is kind of coupled with this piece, and that's kind of unclear. Well, let's see if we can clear that up. The other thing that I'll mention is one thing, and this is something we could be better at, is commenting what the unit is. That's sometimes a good thing that's missing, because a class name usually doesn't kind of describe all the little details of what a unit is. So I do those comments too. Like at the top of the class, I say, here's what the basic function of this class is, unless it's completely obvious.
I think that's what came out of the talk with that engineer as well, right? Is that I think we agreed on medium where like it makes sense to comment units of like maybe a class or a module or a package or something saying what it does. But if you're at a point where you need to comment blocks or lines within your code saying, oh, this actually does this, then you're doing something sneaky with that code that's not obvious to everyone else. And you shouldn't have to comment out or comment something saying, oh, this is what this if block does, or this is what this loop does, or something like that. If anything, we try to at least pull those blocks into smaller methods and give them their own names, so then they're again self-documented.
Yeah, I think that's a good point. I think that's a good point. So, yeah, 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 I think that's a It's a little bit, it's definitely a controversial thing. We've had a lot of people kind of come to us and say like, well, can you write any comments? And I will concede that every once in a while it does bite us, that things kind of get, there's just enough units in play that we kind of forget like, oh, well, this is what this unit is supposed to represent. But compared to like what we had before where you have like, I mean, my favorite is when you have like a comment that's like multiple lines, that's like, you have like a function that has a giant comment block, and then the function's like just a couple lines of code. I remember like seeing lots of code like that.
And the other funny thing is when you use IDEs these days and refactor stuff, right? Someone wrote a comment somewhere and then stuff moved around, and then you come back a year later and you find a comment that's out of place. It's like, wait, what is this doing here? Right?
One of my favorites, this is again from my old team, there was like this really hairy piece of code, and then there was just a comment that was just a sad smiley face. I thought that was not with me. It was just like they didn't even have words. They were just like, this sucks. Okay, so common TDD pitfalls. I have a legacy system. I can't write unit tests. It's impossible. The whole thing's not set up for testing. This is a difficult boulder to overcome. There's a book that I have at the end of this that has some good strategies for doing that. The one that I kind of subscribe to is what they call the spring strategy. Is that spring seed?
I don't remember what it's called. But
the idea is that when you do your new thing, you make sure it has a test, and then you figure out how to kind of bolt that on the side of your legacy system. And if you kind of set that precedent, hopefully people around you will also start writing tests, and eventually what you can do is you can deprecate all of the stuff that doesn't have tests. That's definitely a difficult challenge to overcome, though. Legacy systems, I don't have unit tests. I want to have unit tests. It's just so hard. I can tell you that it's a long road, too. Like, you can't just, in a month, switch the project to a test-driven approach. It takes, like, a couple of years of effort, and it takes a lot of discipline, a lot of hard work. Writing tests is hard to do. Yeah, well, we need to all learn new skills every once in a while. I know that like when I started on the new team, I struggled to write tests. I didn't know, it can be hard. Like you can say what you want the software to do with language, but it can be hard to kind of take that leap and write that as a test. With practice though, it gets really, really easy. I can just tell you that. I don't understand what tests to write. Again, that's another thing that just kind of comes out of practice. You've got to learn how to take the kind of, I can say what the software is going to do now, I need to write what the software is going to do. And then this is taking too long. That's another one, and it kind of ties back on that controversial speed improvement back there. It is going to take a little bit longer at first. My mentor that taught me all of this TDD stuff said that it's not just taking longer, you're learning, right? And the fact that you have to kind of slow down is you learning stuff about your software. He said this great thing. He said sometimes people will sit down and they'll try and write the test and they will be unable to write the test and they'll say, this whole TDD thing is stupid. And he said that like when it's hard to write that test, you may not want to admit it, but it's because you don't understand what that software is doing. Because if you understood what that software is doing, the test should be pretty easy. And so you have to recognize that at some point you're just kind of learning. You have to go with that flow. Okay, so the big takeaway of all of this is if testing is hard, listen to the test and revisit your design. That's the one point I would want to like kind of drill home all of this TDD business. I said that I had a book for you guys. If you guys ever want to, if you guys are very distraught or you need some strategies for getting TDD tests in code, this is a great book, Mike Feathers. You brought a copy in and we all read it.
They didn't have us, even though we were like a TDD team from the beginning, right? There's always...
Oh, here, I'll stay away.
There's always legacy code in any reasonably sized system of any reasonable age, if you will. And so this is always useful for any kind of code base.
Yeah, what I really like about this book is it's kind of where I pulled some of these pitfalls out of. There's like chapters in that book that say, oh, the test is so hard to write. And then they have, a whole chapter about like, well, this is why it's hard to write. It's okay. Here are some strategies for making it easier. And then the best thing I got out of that book was that, I can't remember exactly what they call it now. The spring, the idea is that if you need to write something that you want to be unit tested in something that's a legacy system, you just kind of carve that thing out all by itself, write tests around that, and then plug it in.
I think also something interesting about the layout of that book is that there's only probably like one small chapter at the beginning talking about tests and design and stuff, and after that it's mostly like a reference kind of thing. It's like, oh, here's the situation I am in, right? Like, oh, here's, I've got like a class that's a single term or something, how do I test it? Or I've got like this tightly coupled set of classes, how do I test that? Right? So it gives you like steps that say, oh, here's where I am right now, how do I do something better?
Yeah, so that's all I have. So let's get questions.
Well, there's another book that both those guys collaborated on, but it's actually written by Robert Martin, called Clean Code. And in there he talks about why to have no comments and why to name things
carefully.
kind of how to name things carefully.
Oh, cool. We should check that book out.
So
Yeah, I think that was like a predecessor. I've not really got a chance to read that, but I think that was before this came out. There was like series of really good books on Agile and TDD
And that one I found online. I can actually download it free as a PDF as far as I can tell.
Okay, we should do that.
Publishers are rolling over in their graves right now. Thanks. Clean Code?
Yeah.
Clean Code, I think that's what a little weird. Does anyone have any other questions? Feel free, like, not only about TDD or dependency isolation, but like if you have any questions about Amazon or like our area. Yeah.
To bring it back to C++,
Yeah.
how did you find the performance, and I know it was different projects between Java and C++, performance in person time and performance on machines too?
So when you say person time, you mean like how long does it take to kind of write the code?
Or
So
productivity.
yeah, so for, I'll start with the machine time. I never really noticed a big difference because so the team that we're on right now benefits from the ability that we're an asynchronous service. So people kind of give us the piece of work and then they wander off and then we work on it on our own time. And so performance is not a big thing for us because we could just basically throw tons of machines, right, at the problem, and we can just parallelize all the units of work. The only thing that kind of really is a performance problem for us is if one of you guys orders like 50 of something, then that causes problems for us. And I don't really have the comparison back to my old team on that performance because like we never dealt with units. My old team didn't solve such a difficult problem. We were more about kind of messaging stuff downstream, and so we never really had to do these complicated computations. So I don't really have like a good performance on the machine comparison. In terms of performance, with my fingers on the keyboard, I'm not going to blame it on C++, but the new team is like, I think we did this the other day. We looked at the number of check-ins I had on my old team, and I was there for like maybe 3 years, and it was less than the number of check-ins I had in a couple of months on my new team. And I'm not going to blame that on C++ just because like the TDD really made a huge difference. The old team I was on, they've since, by the way, rewritten their software, and now they're going faster than us. But the old team I was on, it was really legacy software. It was from the days when like Amazon.com had one warehouse. That's like how old some of that stuff was. And so it was just really hard. Everything was really slow going.
Also, if I had to add to the machine time thing, it would be more of, I don't know if that's necessarily Java versus C++, because I think a lot of the things he mentioned where you have 50 units and takes a long time is just inherently, the problem you're solving is a hard problem. In fact, it's an NP-hard problem, and we have heuristics to solve that. So I think a lot of that is not necessarily C++ will make it any faster, it's just because, and we are mostly because of service-oriented architecture, we spend a lot of time calling our services. So it's not that you're so CPU bound that your raw processing performance actually matters as much as it would for a pure C++ program.
Yeah, we're usually standing around waiting on a telephone line for someone, figuratively speaking. Yeah.
So do you maintain 100% test coverage?
Yeah, so that's actually a really good question. I sometimes get that one, like, oh, do you guys check your coverage? We actually don't check our coverage. We occasionally kind of run it just by hand, and I think we're up in like 80, 90%. The reason that we don't check the coverage, there's a couple reasons. First of all, like the most practical reason is we hate testing getters and setters. That's a whole other like kooky discussion that you can get me going on though, because if something doesn't need a test, then you probably don't need to write it, but we're going to get into some really crazy arguments if I go down that line of thought. So we don't, to answer your question quickly, like we don't really look at our test coverage, but it's pretty good, and I think we just rely on the fact that like we're all really disciplined about write the test first, and make sure that I'm not writing any code without having written a test.
Do you test all the exceptional paths?
Yeah, so
Usually
the way that works is that it's like, okay, I'm going to test the basic path, right? And so I'm going to write my basic test, and I'm going to implement that. And then in implementing that, what you'll see like, oh, interesting, what happens if I call this thing and there's nothing there? Then that's going to throw an exception. And so then what you can kind of do is you can quickly snap back to your tests and say, well, you can do one of two things. You can either write the test right there and say, let's instantiate this without whatever needs to be here so that it's a null pointer or whatever you need to do. And then you have both tests and you kind of make them both green at the same time. Or what my mentor used to do is he used to just write it down on a pad of paper. I wish I had that discipline. It was like the most amazing, it was like some sensei stuff. He used to just sit there with a pad of paper, and as we worked on stuff, he'd just write it all down, but we'd keep going without even pausing. And then at the end, he'd be like, okay, so we need to check that we need to check when the array is empty, we need to do this, we need to do that, we need to do this. Usually I'm the kind of guy that snaps back, writes the other test, and then snaps forward. And that's discipline, and I was actually thinking about this the other day. These days it's discipline I didn't even know I had, right? Because I just do it naturally. I feel dirty if I kind of say like, oh, okay, well I know what's going to happen if this exception happens. I'm just going to take care of it right here in the code without having written the test.
I'm assuming you are using JUnit here, but is there any other framework that you are using?
So we use JUnit, we use EasyMock for the mocking, and we use Makito. There's some of the what is that stuff called? That stuff Olix likes to use, where you get to make the assertions read like English.
Oh, like the matchup stuff? Yeah. I mean, that's just an
cool.
addition to JUnit, the Hamcrest stuff.
Hamcrest, that's it. Yeah, you can tell I don't use it. Trying to think, is there any other? We use Spring. Spring's kind of an important part because it manages all the dependency injection. And actually, when I was preparing this, maybe you guys know this, is there a notion of dependency injection frameworks like Spring in C++? The idea that you can say like...
They made it for .NET, Spring.NEt, but I don't think they...
Yeah, I mean, I think one of the things with C++ is, I mean, it's good and bad. It's like they don't really have reflection or kind of instantiate stuff at one time. So I don't know. I mean, I think the way they usually do it in the C++ world is they just have stuff that generates code that does it for you, right? Instead of just looking it up at runtime.
Yeah, so the reason I was thinking about that is one of the problems, like if you go back all of the slides to that whole, the gateway with the different implementations, like one of the things that can be a little bit crazy with all of that is that you've got to manage all these implementations and you've got to plug the right ones in at the right time. And like two things I'd say about that. Well, first of all, in Java, like Spring kind of makes that really easy, and I didn't know, I tried to find, I just didn't have time to really dig deep enough, but I tried to see if there's something similar in C++. The other thing I'd say is you can kind of whittle that down. You don't need to have quite that many implementations. I just wanted to break it down into the simplest parts. So you can combine some of those pieces into one thing that kind of can spy on the service and can also act as the replay. Just using kind of tricks of Booleans and instantiating it the right way. Yeah.
Do you run your test on your development machine, or you use some special topology?
We have so many layers of tests that it's kind of crazy. So we have if you remember that pyramid, there was the unit test at the bottom and the system-wide test. We usually run the unit test on our development machine, forget to run the system-wide test on our development machine, but then we have a continuous build system that runs all of that. So the kind of standard thing that we always do is we forget to run those system tests, and then we break those tests, and then if we were good developers, though, we would run all of that stuff. We can run all of that stuff on our development machine. Then we have a couple other layers of tests that stack on top of that, as I said, when we start rolling out, when we start deploying stuff to like that depot environment or the production environment. There's a number of other tests that are running, and you can those don't really run on our desktop. You can do it if you really kind of squint at it and kind of line up the stars the right way, but we generally just don't.
It is in continuation with each question. The cases that you run, the test cases that you run on the test box, how do you select them? That for a given change, what are the test cases do you need to run?
Yeah. How do we select them? We've actually done kind of a lot of interesting discussions about this. So at the basic level, basically, we have our code kind of broken down into a couple packages, a couple big packages. And so usually what we do, we all use Eclipse. And when you kind of edit things in Eclipse, there's a little star that shows up on the package that you've changed. And so you kind of go through and you run all of the tests for that package. And Eclipse kind of makes it really easy to do. So that's kind of the basic way that we select that. Now, some of our packages have so many tests that it kind of takes a while. Like the individual tests don't take a while, and hopefully your unit tests don't take a super long time. But sometimes we just have so many of them that in aggregate they take a while, and so sometimes we skip that step. And then we kind of go with the Java package layer. So you kind of pick the hierarchy that you kind of, it's all a risk assessment. So you're basically weighing the risk of, I check in my code and I forgot to run a test, and it breaks the build, and then I have to, by the time it breaks the build, I've moved on to something else, so then I have to come back. So we all kind of do that risk assessment in our head.
So is it developer's discretion entirely, or?
It is developer's discretion up until you hit commit, but then our continuous build system will run all of the tests.
Yeah, before. I was asking that part that you run on the developer
side. There is, so the reason I said that was interesting at the beginning is I did look at, there's some plugins for Eclipse, and I imagine that this kind of stuff exists for any IDE that you kind of do, and you can probably hack it into Emacs. And if you're using VI, I'm sorry. Just kidding. You can probably hack it into VI as well. But there are some things that can do some clever stuff, like they can look at the code that you're changing, and then they can say, like, as soon as you hit save, start running the tests for that kind of logical piece of code. There's even like stuff in Java where they will try and figure out what kind of pieces of code this will touch. That's kind of dark magic, dark Java magic. And you know, we experimented with some of that stuff, and I didn't like how any of it turned out. I didn't really spend a lot of time doing it, though.
We talked about code coverage. One of the things that you get from the same data that generates code coverage is that you get that impact relationship. You know that the code that you change, how many test cases we are passing through it, just by looking at the reverse way.
Oh, because you can see, like, oh, these are the...
Yes.
Oh, interesting. Yeah. Sorry, was that a question?
Yeah, that was just basically to make a comment that code coverage is not just a percentage thing. It gives you, the same process gives you, if you look at the other way, the impact.
Yeah, so I think what you're saying is as you change code, if you flip either code coverage on its head or you're constantly running your unit tests, you can figure out all of the
from the
test
past
cases
data you can calculate. Suppose you change just a function. You know that what were the cases that were going through it.
Are you trying to say that you can use code coverage to prioritize your tests so that it hits the churned code?
Can you use code coverage?
You can.
Yeah.
That's what I'm saying.
So, okay. Yeah, got it. All right, and actually we have another thing. This I think is not Java specific, but there's something called Sonar out there. Has anyone heard of that? Sonar is kind of a cool product, and if you kind of hook it up all the right way, it can do a ton of stuff like that. So it can do things like match up what's the code that you're changing most often. It'll look at like your commits. It'll say, oh, you're changing this code a whole bunch, and its test coverage is really low, and so it's a really risky point. And it can do all sorts of stuff like check your style and do static analysis and do all sorts of stuff. And we have an instance of that. We don't pay as much attention to it as we should. More?
So do you use PMD or check style or any of those other code quality tools?
I think Sonar runs through all of, so Sonar is basically this layer on top of all of these check style and PMD, and I think it's got some more checks on its own. And it basically aggregates all of those, gives you metrics, gives you graphs, and tells
But it doesn't block commits or anything?
we can set it up to do that. We've not got there yet. That's something we should really do. Right now it sends us emails. I think we tend to ignore it.
Email that goes straight to trash. Yeah, no, usually what happens there is that you can email, get a couple emails, and then, okay guys, like, can someone do something to stop all these emails? You know, everyone has room for improvement. But yeah, we don't generally run as part of like the developer when we're sitting on our IDE. We don't run check style. We don't run any of that stuff. Yeah, static analysis.
Okay.
I'm getting the thumbs up from back there.
Yeah, you guys gonna be here for a little bit?
Huh?
I'd say I kind of want to wrap it up here, so
Yeah,
if anybody
totally.
needs to get going, they can get going. If you got some more individual questions, feel free to talk to these guys.
I have business cards up here. I didn't kind of share my email. I should have put it on this last slide. But it's really easy if you, it's Matt Beck, MATTBECK at Amazon.com. If you can't remember that, I have a nice pile of business cards up here. You guys are going to email me.
Okay, thank you much.
Yeah.